Hi, a very good afternoon to all. We'll start with our webinar today. So climate change is a real race against time, and we must achieve our global climate targets for a greener future. The impact of efficient infrastructure accounts for a significant reduction in amount of global greenhouse gas emissions, making clean, sustainable energy the top priority in the fight against the climate change. For a brighter, greener, sustainable future, we need to act now. Today, we have tech-enabled digitization, which helps us advance and achieve our shared social and environmental goals. With this, we shall start with our second webinar on solar sustenance and infrastructure projects. So, today's agenda for the webinar, we shall start with a company introduction by Mr. Shitanshu Jain, Regional Sales Manager, AC Infrastructure of Capricorn Technologies. It shall be followed by a technical session by Mr. Tanmay Bhalerao from Autodesk, covering solar sustenance, optimistic site planning, shadow analysis, and many more sustainable features. Then we shall have a guest speaker, Mr. Samrat Singh Gupta, VP of EKI Energy Services, sharing his views and experiences about the industry, which will be followed by question and answer session, ending with the vote of thanks. I would like to request all the attendees to keep on writing their questions in the chat box so that we can come to them later on. Now, I would like to invite Mr. Shitanshu Jain, Regional Sales Manager, AC and Infrastructure, Capricorn Technologies, to take over, sir. Over to you, sir.
Thank you so much, Naman. Can I just share my screen? We'll have to stop sharing it. Yeah, Naman, just confirm if I'm audible and the screen is visible.
Yes, sir, it is.
Perfect. Thank you. A very good afternoon to everyone from fellow colleagues in the construction and design industry. So I'm Shitanshu Jain, part of Capricorn digital transformation team, helping design and construction technology enablement in your organizations like contractors or government organizations, developers, etc. So today's topic, the main theme, which is around sustainability, is something which I believe has been is impacting all of us in our daily lives. We are seeing in media what is going on around the world, in India, in our localities, today, yesterday. And this is not something which has happened, say, suddenly. Probably over last 50 years, 5 decades, or whatever decades up, it has happened because of what we have developed. The development has happened probably much faster in last 50 years than what has happened in last, even for example, 5,000 years. So now today the question is on us, or the decision is on us as an individual, as an organization, as a government organization, as a country, as a nation, as the world, what we are going to do for our future. How do we, where do we go from here? We have like multiple paths from here. Either we can take a decision to change our way of working now, or we see what is happening is only going to get worse from here. And we believe that, like Naman also mentioned, that construction accounts for most amount of carbon footprint or energy waste usage across all the industries. And if in our way we can help reduce that, we believe that we can contribute in going towards the positive path. So today's topic is specifically around infrastructure projects and solar sustenance. Infrastructure projects, which are primarily, and we focus primarily on the large scale projects, they can contribute heavily into your sustainable improvement going forward. And if we have the right technology and the right tools at our disposal, which we do, and if we leverage them properly, we believe that we can do wonders for our future generations. So with this, I'll just take a couple of minutes to introduce who we are as Capricorn and what we do, how we can help you, and then we can take it forward more towards the technical discussions. So as Capricorn, we are India's leading digital and construction management technology solution provider. We have been there since 1987. So we have more than 3 decades of experience in helping our customers uh, and use technology. So back in 90s, we started with CAD usage. And now for last 2 decades have been focusing around BIM and more automated and cloud solutions and how they can be used and leveraged to help you be more sustainable in your projects. So we are heavily focused around the AEC industry. So more than 20,000 customers in AEC in India itself, and having a very tech savvy team focusing on different parts of construction projects, starting from design to construction to O&M, FM, etc. And have base across the country. So wherever your project is, we can support you either in your cities or remotely as you feel, as is your requirement. And one big change which has come recently in Capricorn is that we have now become a part of a bigger umbrella, which is called WinZero Group. And we have a global footprint now. So we are based out of US, UK, Australia, and India. And the idea behind that is that how do we enable more sustainable practices in the AC industry, standardized across the world. And second is, how do we bring more mature technologies, workflows, practices from more mature countries into Indian landscape? So that is our idea of this organization. Our bottom line is, how do we enable sustainability today, tomorrow, and make this world a better place for future generations? So with this, I would like to thank you on behalf of Capricorn, and would like to hand it over back to Naman to take it forward for more of technical discussions. Naman, over to you.
Thank you so much, sir, for the brief insight. Now, I would like to request Mr. Tanmay Bhalerao to take over for this technical presentation. Tanmay, over to you.
Sure. Thank you, Naman. Thank you, Shitanshu, for the introduction. So I'm just going to share my screen and get started, but would like to thank every one of you all for attending, and thank you for your time. I hope everyone enjoys the presentation as much as I love delivering it. And just going to share my screen, and Naman, please let me know once you can see it.
Yeah, Tanmay, we're good to go.
All right, perfect. So let's get started, right? So the topic for today is going to be focused on, you cannot talk about sustainability without talking about solar energy, right? The sun is this handy fusion reactor in the sky, in the words of Elon Musk, right? That shows up every day, gives us insane amount of energy, and then shows up every single day reliably. So insane amount of energy is the right word. When you compare the amount of energy we receive from the sun and compare it against all the other energy sources that we have today, or even the entire world's energy use, everything is dwarfed in terms of what is available to us through this solar resource. So only if we are able to learn and improve improve our speed of building out solar capacity, that would go a long way in ensuring we capture and move towards a sustainable planet. So the agenda for today, in line with that, is going to be focused on digital transformation in solar in the Indian context, then looking at engineering and construction and operation automation to that kind of enables this digital transformation. And then we will move on to just look at a customer story and some call to action that we have. And the image that you're seeing is an image of a sample solar plant POC that we did for a customer in India using our tools. So we'll get a look at some of that as well. So if we, before we get started, just to get everyone on the same page, right? What is India aiming at? What is our installed capacity today for solar? And what's the scope of this industry, right? So if you see, this is a heat map of all the solar capacity across India by the different states. And these are the respective numbers if we kind of were to do a leaderboard and kind of see how many of the solar plants have been commissioned versus how much have been in pipeline. So just a total of 81 gigawatts is what we have. About a decade ago, our government has set an ambitious target of reaching 20 gigawatts by 2022. And within a few years, we already exceeded that target. So we became more ambitious and we upped that target to 175 gigawatts by 2022. And now we are looking at an even more ambitious target that by the end of 2030, India's renewable energy capacity should be 450 gigawatts, and 60% of that should be coming from solar alone. So to take that in context, we need to be building 25 gigawatts of capacity every year, and we are nowhere close to that right now. So what are some of the industry innovators learning from the digital transformation that's happening or taking place in the AC industry today? So every one of you is familiar with AutoCAD, is familiar with design. Over the last 4 decades, we've come a long way from CAD, come a long way from manual drafting, right? So if the first 20 years were focused on CAD since 1980s and 90s, so there was a slow shift happening towards BIM, which took about 1.5 decade or so. And now in the last 5 odd years, especially expedited due to the pandemic, there's been a shift towards cloud collaboration. People want to be able to work anytime, anywhere. And just like you access Google Drive or any of your basic data on your mobile at a fingertips, why shouldn't you also be able to access all the design data in the same manner, or be able to design in the same manner, right? That's the shift that has been observed. But now what we are seeing is, and there has been a catalyst, right? There has been a key catalyst for each of these transitions. Like CAD saw a boom because of the personal computers. Modeling and BIM saw a boom because of new ways of increasing productivity in light of downturns, and then also government mandates were coming in place. And as we went through the last 2 years of pandemic, we saw a shift to the cloud. And now what's happening is all the owners, right? Whatever the developers, facility owners, whoever they are, they want access to data, and they want to be able to gain insights, analyze insights, analyze that data for useful insights, and be able to make their decisions to increase the efficiency of whatever facility they are owning and operating, right? So that's why now we are seeing that the complete picture of what BIM started with early on, right? Moving towards a digital twin. So that is just what we see from an industry standpoint, and what we are seeing that getting applied across all industries. But when we think about solar project, how does it look like? What does it translate into? Right? Typically today, if let's say this is a sample calculations that have been done, estimated based on industry references. So if let's say we are looking at a 750 megawatt solar plant installation, rather than taking the usual 13 to 15 months timeline, we are looking at bringing that down substantially. And this is the breakdown of all the different stages and the potential timelines with several digital transformation initiatives across all of those stages. So that's only about the time aspects of things, right? But there's at the end of the day, everything is about cost and sustainability and impact as well, as much as time. So increasingly, innovators are looking at new ways to just radically transform their design such that they can reduce the material costs itself, right? Any earthwork quantity optimization, placement of solar panels such that you're maximizing the use or optimizing the structural usage, right? Optimizing it for steel tonnage that gets used for the support structure of the solar panels. And then as you go on to pre-construction, constructing it, you want to eliminate any constructability and planning issues. You want to be able to have before you actually go out and finalize a design and build it, you want to select a design that's optimal. In order to do that, you need to simulate it across several different scenarios. And then finally, once a construction, as you progress towards construction and operations, you want to do that much more intelligently, taking into account all the data. So that is basically why the time and the cost aspect of why industry leaders are looking to get their competitive edge through for those reasons. But how do they do it is about you can, when we think about engineering side of things, and we'll also look at construction and operation in a minute, but when we just look at design and engineering side of things, for solar projects, there are three broad buckets that we have identified, where before a project is put out to bid, um, uh, the key area of improvement is improving the accuracy of the yield estimation. Not just the accuracy, but the time it takes to arrive at that yield estimation as well. So when we look at yield estimation accuracy, we are going to improve upon the existing conditions modelings, surface analysis, module layouts, shadow analysis, and finally yield estimation itself. But when the project moves on to detailed design stage, that's where again a lot of automation can bring in a lot of time savings and cost savings by doing grading optimizations, one-click layout of the entire plant, while ensuring you avoid all the shadow areas or all the other areas where you cannot realistically lay out a solar panel. Doing structural analysis while taking into account the material, the steel tonnage that is required for that structure. The wind loads are going to be maximum at the exterior of a solar plant, whereas the inside, all the solar panels or the support structures that are inside a solar plant at the inner areas will face limited wind loads, right? So there is an opportunity to optimize. You don't have to have a constant design across the entire solar plant, right? You can analyze the wind loads that are forming and design for those specific wind loads for those specific conditions. And then of course you're working in a model-based design approach so that all the downstream activities are fairly automated. So all your bill of material generation, so quantity takeoffs and such, or plan production, right? Those are the two main activities that happen, need to be automated and are able to be increasingly automated. And then as we move on to construction and operations, the three buckets here that we've identified were project planning, execution, and commissioning and operations. And I'm sure a lot of you have seen some of these words before, so we won't spend too much time on it, and we are going to dive into the presentation as soon as possible. So these are just basically some workflows to help you achieve that excellence in those respective areas of improvement. And what helps you get there? We looked at the why, how, and these are the products that enable you or equip you with the workflows to help you achieve those end outcomes, right? And we're going to look at each of these things in detail as we move forward. So now, first step of any project, whether it's any kind of industry, right? You have to capture the existing conditions. You need to digitize the entire base map. And most often in India, we do not have the data that is required, right? In developed countries, it's available very easily. In India, we are now starting to look at and investing in new technologies that helps us radically transform this process, this time-consuming process of getting raster images, manually drawing over and digitizing a map, so that we have the most accurate representation, digital representation of the reality. So how does it look like? So typically the as-is workflow that we observe in the industry is predominantly AutoCAD based and GIS based, where you get access. The designer has to almost, in most cases, the designer has to wait until they have access to the total station survey data. or the topo survey that gets done on the field, and is not they are not really able to proceed further without a lot of R&Ding by themselves. So get the raster images from different websites, uh, check all the different sources for which is the most accurate one, get the dem file from different sources, overlay all of those, and then have a surface to work with uh, until you actually get the topo survey done from the site. And then, of course, if you have any GIS data, you can integrate that. Only after you do all that can you actually do surface analysis and any kind of feature extraction on that surface. So the proposed workflow, and you'll see some of the things as we show in our presentation, is and for those who joined our webinar yesterday, they must have seen some of these workflows in InfraWorks as well. Within one click, you're able to quickly get the raster imagery and the elevations or the DEM file of that entire land parcel or the site boundary. And you can start working on it with advanced design and simulation capabilities. So, and taking that one step further is more and more scanning equipments are becoming far cheaper. Over the last 10 years, the prices have dropped a lot, and that has given rise to many companies investing in LiDAR scans, and if not LiDAR scans, at least photogrammetry scans, so drone surveys that capture photos of the entire site. So we have the tools that essentially let you feed all of that data that gets captured from the scans into our software, and then finally give you an end result of the 3D surface that you're looking for. So an example of that is what you're looking at the screen, the top one being a photogrammetric output and the bottom one being an output of a LiDAR scan. Of course, a LiDAR scan is far more accurate than photogrammetry, but also is far more expensive. So according to the use case, according to the importance of that particular land parcel, people evaluate on what technology to invest in. But no matter what you invest in, you need to make sense of that data. A drone can go over the site and capture all the photos, but you need the software to be able to very quickly stitch all of those together to create a 3D mesh. You need smart tools that give you powerful, equip you with powerful workflows, that if you have access to LiDAR scans, then you can extract any linear features or vertical objects that are observed in the scan. So there are powerful algorithms that kind of join all the points together to extract a linear feature. Let's say if it's an edge of a street, right? You can select a point and another point along that street, and it will extract the entire street from start to finish. So that's the feature extraction workflow that can again enhance and save a lot of time when you look at digitizing a map. And obviously, if you have access to GIS data, you're going to use it, right? But you don't. GIS data is shape files and it's data, right? It's just 2D and it has a lot of attribute information to it. But what we have is the ability to kind of seamlessly integrate with GIS such that whatever, let's say there's a drainage network or a pipe network, right? In the GIS format, you can bring it in, and then whatever attributes are given in that drainage network, let's say you just have a sketch of a pipeline that goes from point A to point B, just a 2D line. And on that line is the property of, what is its invert elevation, what is its diameter, and all of that. Our tool can actually read those attributes and automatically model that pipe network for you. So that's the power of it. There's no need to reinvent the wheel. Wherever you have data, just automate the creation of the 3D model from that data. That is possible today. And as I was talking about earlier, one click of access to a DEM file. So the raster imagery overlaid on top of the elevation model. This is what I was hinting at earlier, right? So let's say you've identified a site boundary where you want to lay out a solar plant. If you have the geolocated site boundary, you can simply import that, or you can sketch it out in a very Google Maps or a intuitive user interface that you have always been familiar with, right? That's the kind of intent or the design of our solutions, to let you not spend or waste a lot of time in searching for how to do things, but take away all of that complexity in the background and let you do the most important design tasks that you're asked to do for your company, for the planet. So this is very quickly, we got the raster imagery, we got the elevation model, so we can also get the contour data of that particular land parcel. And let's say if this was our, we can start sketching out our site boundary, and we can start doing the grading, shadow analysis, understand the hydrology of it, and then further optimize the grading of it as well. And we'll take a closer look at all of that. So today, a lot of customers that we see and meet with are kind of still restricted to some sort of an semi-automated way of uh, understanding areas where the shadows are forming and avoiding those areas for placement of solar panels, right? Because that's the one of the most important things. You cannot uh, you cannot you have to evaluate for real world conditions and be able to simulate the shadows, because even a small shadow in a small part of a solar panel or the connected solar panels is going to disrupt and reduce the energy production, electricity production. So with the same tool that you were looking at earlier, whatever structure you model or whatever structure that is already extracted for you, the shadows and the sun and sky settings are easily altered. You can check for all the extremities of the year, any day of the year, any time of the year, and check the maximum shadows that are forming and quickly draw out those areas, and then block and then export those out as a different layer, such that when you go out to place the solar panels, your script or your draftsman will avoid that area for solar placement. And then when we have access to our surface, of course, as we move forward, we want to make sure we are designing our solar plants or whatever infrastructure we're designing it for a very long life cycle. We want to ensure that we design it for all flooding events in the future, right? So being able to simulate those conditions, and then through those analysis sizing our drainage network to be able to handle that is also something that is or has traditionally been a time intensive, time consuming activity. And because it's kind of been static and in an Excel based workflow, a manual workflow, it's also been prone to errors. So how do we limit human interaction wherever possible and automate a lot of things? Here's a quick video on that. If you were to just quickly understand, there's a surface that you're working with, these are the contour lines, and if you had to identify what's a watershed, where's the watershed or a catchment area forming on the surface, manually, if you had to do it, you're actually going to sketch out a line perpendicular to each of the adjacent contour lines until you can no longer do so, and that becomes your catchment area. Whereas in the workflow that we are recommending, which is now what you're seeing here, is we have something called a water drop tool, right? You can just click anywhere on the surface, and it will give you the exact path that a water drop will follow, so that you very quickly not only visually see, but it's actually taking into account the triangulation of the surface and actually generating the entire catchment area within that surface. And we'll take a look at that also within a minute. And for those who are who want to get started very quickly in a very easy to use environment, this is InfraWorks, right? This is a tool where in a real world situation with a simple point and click approach, you're able to carry out watershed analysis. So you can just select a point or select a road across the stationing of a road from one point to another, And the watershed analysis is going to automatically identify if any streams are crossing over from that road. Or you could check the same thing for different points along your solar plant as well, right? So in this case, what you're seeing is very quickly, this entire giant watershed has been identified that is getting formed at the north end of your site boundary. So of course, you can imagine that if there's a lot of rainfall, the north side of your site boundary is probably prone to some sort of flooding, and you need to be able to account for that. And if you have any roads that are crossing or approach roads inside of your solar plant, where you need to lay out your drainage network or lay out any culverts between those roads, under those roads, it's as simple as being able to simply select that particular infrastructure. Now, in this case, we can see that, there's that marker out there. And I'll just go ahead a little bit to showcase in the interest of time. Like in this video, I again test out a different scenarios at different areas in my project. There's some catchment that's forming on the south side. There's something that's forming on the north side. There are some streams in the middle. And I can see that this stream is crossing these two roads. So I certainly need to ensure and take care of the water that will be flowing. So I can simply right click the road and say that, add culvert at that location. And it will automatically place the culvert based on the direction of that stream. And if you had provided the rainfall data, you will be able to size that culvert as well, right? So that's, and again, in the interest of time, I'm going to move a little quicker through some of these workflows. But this is not just for culverts, but you can, with a simple point and click approach, you can lay out an entire drainage network. As you can see, some of the inlets that have been modeled. You can specify the entire geometry, and the performance of those inlets are automatically simulated based on the hydrology method that you select and the peak flow data that you provide, which is the rainfall data for that particular region, right? So based on that, we are able to do the sizing calculations that are needed for the drainage design of that particular area. And then, of course, you are able to, those were the larger catchments, watersheds rather. I end up using those two words interchangeably all the time. So those were the few larger watersheds that were forming on our site. But let's say if you want to analyze all the different smaller catchments that are forming across the areas, all the waterlogging areas, right? So in the context of the map, of the map imagery that's coming from Bing Maps in this case, we are able to, all these lines, all these areas are actually catchments that are forming. And I'll show that to you also in a minute. But the same water drop tool, wherever I'm clicking, it's drawing out a white line, as you can see, right? Wherever you click, it's showing you the path that a water drop will take. And it's being able to show you, where are, all of these water drops eventually going to end up. So that what could be your potential drain targets for most effective drainage design for all the different areas within your project boundary. And now to explain a little bit of what exactly it is that you're seeing, it's a 3D surface, and it's just a visual style of watershed that has been applied. And automatically we get these watersheds classified by different colors. You have your depression areas, you have your boundary point areas, and you have the ability to customize it to the way you want to customize it. If for every area you want to see the points where you should be placing your drain targets, you can turn that value on, and you'll be able to see that in the model at the same time. So for every catchment, what is the most optimal drain target point where you should be modeling a drain, or where most of the water will be accumulating, right? That's the kind of and without, this is inbuilt, like you create the surface and this is just a surface style that lets you see all of those things. So we will validate that also in a minute. So now, as you can see, all of these points are nothing but the drain target points. Of course, now in this case, there are too many because of various reasons, which we won't get into right now. But now, no matter where I'm clicking, again, running the same water drop tool, no matter where I click, the end path of my water drop will always meet some or the other drain point. So that's how you can validate the design. And all of this happens because each and every point here has an elevation, because it's a surface that has been drawn using thin lines. So triangulation is letting the software know the elevation of every single point between the topo survey points as well. And then if we look at grading, the next thing is going to be, you identified the areas where the shadows are forming, you identified the hydrology of your land parcel, but now you want to ensure that the grading of the land parcel is also such that it takes into account the shadow areas, it takes into account the hydrology, and you can specify your constraints. So let's say this was a land parcel. This is just a sample representation of course, it's never this ideal. Of course, the layout rarely is ever this clean, especially in India. But let's say this was a sample solar plant layout that you had. And these were all the table layouts of the solar plant, the array layout that you had done. You want to be able to identify very quickly that if on this surface, taking into account the elevations, remember the darker parts, the visual style of the surface is that the darker parts are at a higher elevation than the lighter shades of blue. So what you're seeing now is just a very easily created Dynamo script running within Civil 3D that helps us identify very quickly across all of these green tables, right? All of these green arrays are actually the solar panels that have been laid out. And we want to see if they were placed exactly on the surface as it is, how many of them will exceed, let's say, 2 or 5% slope gradient, right? If they exceed that gradient, they're going to put their shadow on the adjacent panels, right? So we want to ensure that that never happens. We want to ensure that all the panels are sloped, are laid out on land that is sloping, such that the shadow formation of one row is not impacting the electricity production in the other row. So with it, what's happening here is we are running that script, and it's actually checking for each table what's the slope along this X and Y direction, along this east-west direction. And then once it's done computing that for all of the tables in our plant boundary, now this is a very large project. You have a lot of tables laid out. Therefore, it takes some time to kind of compute it. And also, I think I'm facing some issue with my video in PowerPoint. It's stopping in the middle. But just in a minute, you're going to see that, all the panels now, as you can see, all of those panels that are exceeding 2% slope have turned red, and they have been moved to a different layer. So we definitely want to avoid that, right? We want to ensure a clean layout of our entire solar plant. What can we do? How can we very quickly generate potential design options of grading of that entire land parcel? You should also note that we need to take into account the hydrology part of things as well. So you have a drain line somewhere, drainage network somewhere within that boundary. You have different zones. You have a substation building pad, and each of them have different grading constraints, right? For every zone where the solar panels have been laid out, maybe you're okay with like a 5% slope or 2% slope, but the building pad has to be flat. The drainage line has to be such that it's sloping towards, or the area around the drainage line has to be such that it's sloping towards the lowest point on that surface. So we have a way in which we can supply all of these constraints. We can feed all of these constraints to the software. And I'll just take it ahead a little bit. This is the grading optimization within Civil 3D, where we can specify our constraints. We can specify our objectives of, we want to minimize the earthwork, the cut and fill that will happen. We want to smoothen the surface, right? Or we want to balance the cut and fill such that the net volume is 0 or whatever it may be. And we want to, we are okay with 1% slope here, 2% slope here. This is the drainage line. This is the lowest point. These are the parameters that I have provided to this algorithm already. And as you see here, this is the window, right? This is right now, before we start the algorithm, before we start the optimization engine, you just keep a look at this particular window, right? Now, what's happening is it's running all the different iterations for the ideal grading of that land parcel across all of these zones, while taking into account the hydrology vectors as well of where is the lowest point exactly, where is the drainage line exactly. And this is what we mean by generative design, right? We supply the constraints and the algorithm runs through all the different options to try to balance the net volume of earthwork that will probably end up being moved for that particular project site. And this is becoming more and more crucial because we're running out of land. We want to produce energy, electricity near the cities, and near the cities, or we want to produce, we're running out of flat lands, right? We're only now getting restricted to hilly areas because other areas are flat land and city areas are very expensive. So as we move towards hilly regions, such approaches in the design are going to be extremely crucial to kind of give us access to new ways of thinking and new ways of designing. And I know we're, again, in the interest of time, I'm going to run through a few things very quickly. And then we'll make sure to leave some time for Q&A at the end as well. But quickly moving on, we do the layout. We will have to also ensure the drainage design, the approach road design, but we'll also have to do the structural design of the support structures and do that end to end such that you do create the model, you build in some automation of very quickly if you can, change the different tilt angles, the leg spacing, front and back leg spacing. You quickly get different design options of that support structure, and you can run a finite element analysis on that particular structure for all the different loading conditions, generate a fabrication drawing and bill of materials, and then send it to your layout so that you're actually laying out this same exact solar panel that's of the make of your manufacturer. Then of course there is one of the biggest parts of a solar plant is the electrical component of things, designing of the substation, the transformers, and the MEP. And we do have some of the tools yield estimates of to evaluate the yield potential of a land parcel, or similarly doing mass flood simulations for a land parcel are some of the different things that we can do, and we will dig deeper into each of these workflows depending on what kind of questions are raised by all the people in the audience. But just a glimpse of some aspects of future of design. We haven't yet seen many people apply it for utility scale solar, but as you can see in this one, it's a layout of a residential development, right? Now, how do you decide where do you, how many units do you place, where do you place them, where's the parking, where's the building, where's the roadway structure, what's the total public space available, what's the total, how do you optimize for views? This is one of our enterprise customers who have actually worked with our consulting teams to be able to create an algorithm that lets them optimize for across all of these 7 parameters. So they decided for them for that developer, solar gain, views, backyard size are really important because they care about the human comfort, they care about the planet. But at the same time, cost and profit is also important because they are in business. They can't just be doing, what's best for the planet. They have to do it sustainably. They have to do it such that they can do it over and over again. So very quickly it generates thousands of design options, and each option gets a score like this. So for example, this layout is getting a very good score for views because you see all the building structures are at the edges. All of them have good views, and it's probably not getting as much backyard size, so it gets a lower score on backyard size. So every single, whether it's thousands of design options, each of them are going to have a score, and then you can simply select those that are more aligned to your objectives or your customers' objectives. And then quickly moving over to, you're finished with the design, you're moving on to the construction side of things. You want to do the progress tracking. You also want to do the entire project and construction management of it. So now you have the model, you have amazing data tied to that model, and it is what's going to get built. So you should be able to connect the schedule and the cost information to all the elements of that particular model that help you downstream for all the construction management activities all the way until project closeout, such that at the end of the project you have is what you call a digital twin. So you cannot have a digital twin without this approach. BIM is essential for an ideal digital twin to have the data that you would really find useful. And if you end up installing any IoT sensor, let's say I wanted to share a quick example of a user who had uploaded it on YouTube. Using Forge, they had created a digital twin of a substation, right? So any data that's coming in of the transformers, breakers, or the battery, whether it's the oil temperature, whether it's the operational parameters that are near and dear to all the O&M guys, are visually displayed, and you can see a time series of it and its performance over a timeline, right? That way you're able to analyze a portfolio, all the different projects at a portfolio level, to quickly identify which are the better performing designs, better performing manufacturers, better performing contractors, and try to replicate those success stories more easily. And there's a success story out there. You're going to see a solar plant that's been laid out, using some of our tools. What you're seeing now is a walkthrough made possible with InfraWorks and 3ds Max. The entire solar plant was laid out along with the substation, along with the adjacent admin building, the approach roads, and all the other city furniture that there is. And it becomes the visualization aspect of things becomes simply a byproduct. And we have several other examples like that. But in the interest of time, for now, I'm going to hand it over back to Naman to carry on with the agenda that we had set for the webinar. And I'll stick around till the end if there are any questions. Thank you.
Thank you so much, Tanmay, for such an insightful session. The concepts along with the technology and the right tools will surely help us in achieving sustained growth and green development. I'm pretty sure of that. So now I would like to introduce our guest speaker, Mr. Samrat Sen Gupta, Vice President, EKI Energy Services Limited. Mr. Sen Gupta is a subject matter expert in renewable energy and low carbon development with 2.5 decades of experience, with proficiency in policy research, advocacy at national and international multi and bilateral platforms. He has been associated with major power producers and power projects in solar, wind, and hydrology industries. He has been associated with government research institutions like CFRI, CSIR, and has represented Indian and South Asian civil societies in various multilateral forums like UNFCCC and G8. Dear sir, I would like to request you to share your valuable experiences. Over to you, sir.
Thank you, Naman. for efficient utilization of the bandwidth, if I am not bringing my video on, is there is a problem?
It's no problem, sir.
Okay, let me continue then. Yeah, sustainability is a buzzword. I am hearing it from my initial days of professional life, and I have seen it evolving from a page 3 or communication perspective material in a business domain to now really driving the finance or trying to drive the financial flow for a business intervention. But still, we have a long way to go. I don't want to be pessimistic in that way, but I want to highlight that I'm not specific to any sector. I'm specific to the economy model we are in practice. We are in from the initial days of this industrialization or industrial revolution in the north, we are in practice of a economic model that believes in consumption. Consumption means growth, and it addresses almost all the parameters of development as being recognized till today. And in the process, what we have done, that we have derived the financial indicators of those growth parameter in such a way that we haven't able to at all internalize the cost of environment and social footprints of any of our activity into any of the product and services that this economy is providing to its consumption model, which relate to unnecessarily and unjustified consumption. Like even today, we are discussing solar, definitely a very breakthrough technology been developed, process related or in the usage of energy usage of energy conversion from a usable electricity doesn't emit any harmful gases. That's fine, and the whole world is going gaga about it. But if you see the development in India, and it is true for many parts of the world, though some of the countries has already understood that and built in those internal parameters of environment into their process of development of all type of renewables, including solar. But I want to highlight that in India, solar and wind is the primary driver of renewable, other than hydro, which has been here for more than half a century now and should be here. We haven't able to learn the mistakes we have done into our earlier development process and convert it. Even in solar development, the project developer and the government comes to an agreement through a process of PPA, power purchase agreement. That's the motherhood document that defines all the cost parameter, levelized cost of generation of the project. And we are very happy we have achieved a 2 rupees price band. But that PPA doesn't give the or doesn't entrust the responsibility of efficient disposal and recycling of the waste after 20 years of the lifetime of the project. So what we are getting into it, that we are recently, we and media is very vocal about climate change for last couple of years, which is happening in international domain for last almost 40 or 50 years, but we haven't noticed the activism part of it. And will be again go gaga about, our media will go shout against what will happen after 20 years when the huge amount of solar waste being left open into the field, because the project developer in their costing has not considered the cost associated of efficient disposal and recycling of that. So is it sustainable? So that's the question we need to answer. So I want to tell, it's related to solar. This is not specific to solar. It's for each and every development process we are having. Presently, we are very vocal or very bullish about our energy storage activity, because that's required for efficient integration of variable renewable energy into national grid. Because without storage, we cannot integrate more than 175 gigawatt of power into national grid, and that's what that 175 gigawatt targets being developed. And if we want to do more than that, we have to do 24/7 kind of power through renewable, which is the recent, we have seen the tendering process being initiated. There are project developer who came with hydro as a solution, who came base as a solution. So on the battery part of it, battery storage system, the world has been pushed to a technology which is depend on few of the rare earth material. And you need to know this technology is one of the newest into the laboratory being practiced or discovered. Why this technology gets sufficiently push rather than few of the old technology that was lying there without any sufficient help to get commercialized, because it talks about few, or it's required few of the rare earth element or few of the minerals which are available, which known availability in the present earth is very concentrated to 4 or 5 countries. That's really support the investment fraternity to control the whole energy security of this, or commercial energy security of this earth, and creates a viable business, long-term business prospects from efficiently, means from popularizing that technology. That's why lithium ion is getting the market, because it's got the push for the investment side in this capitalist world. Because we India also, almost all 99% of the new battery storage system developed on those technologies. We doesn't have the production capacity, we doesn't have the any of this material security within our geography. What will happen for any geopolitical reason that security gets disturbed? We are in a coming out from a petro economy to a electro economy, and we are getting hostage only the in the same way. Only the earlier the OPEC was our controller, or US, OPEC and Russia was our controller being a main producer, and now we will be controlled by another few corporate houses which runs from 5 different geographical region, who has control on those resources of lithium and cobalt. So we need to, maybe we have understood the problem, but our address to the problem is yet to be get it full efficiency to address the efficiency and security aspects. why government of India's all policies are technology specific, not output specific. The policy should be driven in a way that it should encourage, give leverage, give supports to technology and material which are recycle friendly. If you go to purchase a mid-range or high-range car today, irrespective of the brand, is it means glamorous or non-glamorous, you have to wait more than 6 months to a 1 year, 1.5 year, because not the brand has got huge amount of booking, but they don't have the supply of the required chip which is required to run the automation system into that car because of the material shortage. So we are coming from a energy transition point without considering the material sustainability of this art. How much material we can produce on that particular minerals or rare earth material, rare earth element we haven't addressed to. I think we should take our technology driven policy making towards more output driven and security driven policy making which are locally available. Why aluminum air battery or vanadium flow battery not being promoted in India, being such a huge market which can driven any technology out of laboratory in a day and make it commercially viable with the scale of the requirement we have? Nobody knows, because there is a vested interest of investment fraternity from the north pushing those technologies. Maybe coming from a business sector, talking in the line may not be politically right, but somebody somewhere should highlight that. Yes, I represent a company which are one of the pioneer, and today the largest company deals with carbon and carbon derivatives in the world. Though there are a lot of uh, negative aspects, being double counting and other thing is there in the system which we need to sort it out, but this is the possibly the only global effort towards internalize the cost of some of the environmental impact into your balance sheet. When we are getting a signal that your emission, if you do not check on it, will cost you in your business, when your ESG rating, which will be primarily based on your emission footprint, will going to make your project positive or negative in your creditworthiness for an investor to invest. That's a good signal. Yes, any abrupt change we may not expect in this uh, in this economic setup, but this is possible a very good step forward to at least incorporate some level of environmental cost into your balance sheet to address the service or product cost that is coming out of that intervention. Will take those parameters well into their domain and bring out some level of efficiency into the system. Thank you.
Thank you so much, sir. Thank you so much for your kind words and your viewpoints towards the sustainable industry. Thank you so much.
Yeah.
Now we would like to head over for the question and answer session. So I would like to request both our speakers to be available in answer.
All right, I'm available.
So the first question is for you, Tanmay. For solar plant design, do we have any way for estimating the output apart from cell workflow?
I'm not sure what you mean by civil workflow, but the only way we have of carrying out yield estimation is through the Revit solar analysis tool. And beyond, and it just does a basic solar radiation analysis. And that's simply used in initial conceptual design stages of a project to track the solar energy potential of different layouts. It's not the final yield estimate that you would be going with. So for that, typically people rely on different software. We do not have that.
Okay, thank you so much for that. Another question for you. Can we import IMD data in InfraWorks to analyze flood conditions at particular location?
No. So a quick answer to that is no. We cannot import. I'll have to check what's the IMD data format, but we have a few rainfall data formats that you can import into InfraWorks. But I'll have to just give me 1 second to check for IMD in the supported file formats. I forget all the different file formats that are allowed. But to your second part about analyzing flood conditions, we have an extensive different software. You do not do that within InfraWorks, and it takes into account all of the different parameters of the existing catchments, the soil parameters, and all of that to simulate the flood condition at a particular location.
Okay, thank you so much. So it's open for both the speakers. Another question: what's eco-friendly alternative for lithium-ion batteries do we have in India?
Yeah, eco-friendly alternatives. I'm not saying I'm audible now.
Yeah, you're audible, sir.
It is not eco-friendliness of the aspects. It is about the energy security aspects which I try to mention, like lithium-ion battery, the technology, the production capacity, the basic raw materials are all being imported in India. And if we make it the backbone of our energy growth, considering the next decade will be electroeconomy, where end-use energy will be pushed for electrification to maximize integration of renewables. If we develop our backbone with that particular technology, any day, any geopolitical event may jeopardize our energy security. It is more of a particular also on the recyclability aspects of the cobalt being into the lithium-ion battery. The density of the cobalt in the cathode and related aspects is so dilute that efficient recyclability of those materials is cost wise very high, technology wise intensive, and we don't have that capacity. So considering Indian market has a huge potential to make any technologically viable options marketable and business wise profitable, we should have push for technologies which are not highly dependent on very rare material which are not available within Indian geography. That was my point. So like aluminum air battery, there are vanadium flow battery, which have lot of challenges if we compare to lithium ion in technological aspects, because lithium ion has got sufficient research boost from the investment community to address all the initial challenges they used to have. So our establishment and our businesses should put that kind of support to technologies which are the basic raw material availability will be within the country and their recyclability will be easy for us for a sustainable future.
Absolutely, sir. Absolutely. Well said, sir. Thank you so much for that. Another question for you, Tanmay. Do we have any special plugin for flood analysis in InfraWorks?
Not at the moment. We had one up until 2 years back, but moving forward, last year we, Autodesk acquired Innovize for $1 billion, and Innovize is a world leader in all water solutions. So I'll put a link into the chat of all the different water products that we have available through Innovize. So because now we have those products available, which are far more accurate, we have stopped support for those plugins within InfraWorks. So the suggested workflow then becomes to export it out and do the flood simulation in one of those tools.
Okay. So request you to share that in the chat box with everyone, and request everyone to go through that link and see all the possible solutions which Innovize offer to our industry. Like to request all the attendees to kindly put in their questions, if there are any. We'll wait for 30 seconds if anyone wants to have any questions answered. Because then we'll proceed towards concluding our session. With this, there has never been more urgent need to create a resilient and sustainable infrastructure than now. And with such technologies and smart infrastructure, we can have a ecosystem that is shaped, which is connected to the real world along with the digital world, making it sustainable, green, and a brighter future for our future generations to come. Together, we can transform the everyday for a better tomorrow. And with that, we'd like to close this today's session. I would like to thank both the speakers and wonderful audience for your time. Thank you so much.
Thank you, Naman.
Thank you. Thank you, everyone. Bye.